is that if the camera stands still, it's completely no motion, it does not triggers any event, so no information at all. The more the speed, it increases the number of events, it triggers more events, and at certain threshold, it creates a noise. A balance between two, a 0.50 meter per second was the one gave the good result. To understand the object size and how it impacts on the accuracy, we kept the distance between objects and the camera from 62 and 82 centimeter. Not much impact, but it dropped over the higher distance between two. Further, we checked how the known objects and the unknown objects, how the accuracy drops over it. The graph-based methods, graph transformer and the graph mixer, both methods were capable to maintain even though the unknown objects came in the scene. The model's size is quite low. It doesn't have a complex computational module. That's why the parameter size is only 3.9 million. Now, with this advantage, it urges us to find out how long it takes, what's the computational or inference time. So when we calculated the inference time of the 30 graphs passing it sequentially and parallelly together, we were able to drop the inference time of those 30 graphs. For ablation study, it was quite important to understand. So I'll take you back to the proposed method. Here, we use k-nearest neighbor multiple times on the query node. So we take one query node and we do the multiple k-nearest neighbor, 3, 6, and so on and so forth. It was important that to understand how many k-nearest neighbor is the best to enrich the information of the query node. So the ablation studies shows that the more we increase, it's kept on increasing the accuracy of the segmentation, but because after certain threshold, over smoothing or overpassing the information, model struggle to understand or differentiate between two neighboring nodes because they were having eventually the same information between two. Finally, the false positive was nothing but the overlap events between two as incorrect predicted events. And we're having 4% in the known objects and the 10% in the unknown objects segmentation. In summary, we are proposing contributing CCM layer, collaborative contextual mixing layer. That layer uses a graph mixer neural network, which is capable to solve the 5 different challenges: low light, occlusion, high speed, direction of motion, as well as the object size variances. The future, we would like to extend our research to find out, can we do this real time? Can we reduce this computational time? And finally, this is I'm sure this is the special decade, and we will have a special time in next few decades that we are going through a technological transformation. We are on the World Economic Forum has predicted that there will be more machines that will do more jobs than the human. And we are excited and ready to be one of the architects of this revolution.